Students, in this video I will go through exercise U6A04 where I will be solving inscribed angles inscribed in a circle. So before I get to the exercise, I just want to quickly take a look at the theorems that you are going to be using. These are the various situations, okay, that you should be aware of. What an inscribed angle is exactly. An inscribed angle is formed by either two chords or a chord and a tangent. So as you can see here, I have three cases where the inscribed angle is formed by chords, and then I can have another case where I can have an inscribed angle that's formed by a chord and a tangent. If you notice, all of the formulas are exactly the same. The angle, the inscribed angle that is going to be half of the intercepted arc. So angle A is always equal to 1/2 of angle B, or arc B. Or the inscribed angle is equal to half the intercepted arc. Anyway, let's get to the actual exercise. Okay, so the exercise looks like this. State if each angle is an inscribed angle. If it is, name the angle and its intercepted arc. So looking at this, question 1 is definitely not an inscribed angle. Because the angle over here is not on the circle. Whoops. Okay, and then angle W is definitely an inscribed angle. So inscribed angle. Angle W intercepts arc YPX. Or angle W is equal to 1/2 of YPX. Okay. Find a measure of the arc or angle indicated. Assume that lines which appear tangent are tangent. So this line here definitely appears to be tangent, so we're going to assume that it's tangent. Since I'm told what the intercepted arc is, and that's 100 degrees, angle R, angle QRS, will therefore equal to half of that, so that's 50 degrees. It's a very similar situation here. I'm given 210, which is the other intercepted arc, so that means this side over here would have to be 150, and in that case then angle LKJ will equal to 75. I have 178. The inscribed angle is intercepting the arc measure of 178 degrees, so therefore angle R will equal to half of that, which is going to be 89. Angle C intercepts arc DE, so therefore angle C will equal to 50 degrees. Again, it's half. Angle K intercepts arc LM, so angle K is equal to half of arc LM. Since I know what angle K is, and that's 61, and I'm asked to find out what LM is, I'm going to multiply both sides by 2. So LM will equal to 122 degrees. Very similar. Here you're given the inscribed angle and asked to find the intercepted arc. So the intercepted arc will be double the inscribed angle. So QR, minor arc QR, will be 92. Here in this case, this inscribed angle intercepts RV. So therefore, angle T, angle RTV, will be half of 82, which is going to be 41. Inscribed angle E is going to be supplementary to this guy right here. And how we know that? This is actually a corollary of the inscribed angle theorem, and that is, well, if you know that this whole angle here is going to be double 105, that's 210, right? And then therefore this angle, what's remaining here, what would that be? That would be 150, right? So that means this angle over here, the question mark that is, has to be 75. As it turns out, the opposite angles inside of an inside of a quadrilateral that's inscribed in a circle, the opposite angles are always going to be supplementary. So again, angle FED will equal to 75. And again, if you don't remember that, you can always reconstruct what I just demonstrated here. Because if you're given one angle in the quadrilateral, the intercepted arc is going to be double that, and then you're going to subtract from 360 what you just found, and then you're going to half that quantity, that difference, to find what that opposite angle is. Okay, question 11. All right, so in this case, you're given 132 and 80, and then we can find out what the minor arc CB is, because CB is going to be 360 minus 132 and 80. So this is the same thing as 360 minus 212. And that would be equivalent to 148. So then angle CAB is equal to 74 degrees. All right, question 12. So in this case, you're asked to find angle R, and I immediately notice that this angle, or this arc, is going to be, again, the difference of 360 minus 96 minus 64. If I combine 96 and 64 together, I get 160. So that means that arc there, arc QPW, is going to be 200 degrees. And arc QPW is 200, then angle QRW is going to be half that. It's going to be 100. Even though we have a quadrilateral inscribed inside of a circle here, we actually do not need to apply that supplementary idea, okay, because angle QRW is not opposite of angle W. All right, moving on. Find the measure of the arc or angle indicated. So for these, really quickly here, angle A and angle X, they're opposite of one another, and this is a quadrilateral inscribed inside of a circle, so therefore I can say 12x minus 8 plus 8x plus 8 is going to be supplementary. I want to add together all like terms, so I get 20x is equal to 180, divide by 20, x is equal to 9. And to find out what yxw is, that's angle yxw is equal to 8 times 9 plus 8, and that would be 80 then. Okay. find angle QPR. So QPR is going to be half of angle QR or RQR. But well, I'm not given anything about RQR. Well, I can certainly find out RQR in terms of x, and that is 360 minus 9x plus 19 and minus 16x minus 5. And if I continue with this, right, I will end up with 360 minus 9 plus 16, that would be 25x. 19 and negative 5, that would be 14. So this would be 360 minus 14. What is 360 minus 14? That would be 346 minus 25x is equal to QR. So if that's the case, then I know that this is also going to be double, or if I take half of this, it will equal to 4x plus 8. And if I multiply both sides by 2, I get 346 minus 25x is equal to 8x plus 8. I will now subtract 8 from both sides, and I will get 338. Add 25 to both sides, I will get 34 or 33. And divide both sides by 33. What is that? That is definitely not an integer. So I'm just going to double check whether or not I got anything wrong here, just because usually these questions end up being an integer. So 360 minus 9x plus 19 minus 16x minus 5. That would be equivalent of 25x. I'll do it like this. 25x plus 14 and subtract 360 minus 14 is 346. That is correct. Minus 25x, and set that equivalent to double 4x plus 8. Oh, see? It never hurts to double check. So that 8 should really be a 16. I did not double it. And if I subtract both sides by 16, I'll end up with 330. Divide by 33, I get 10. So x is equal to 10. And then QPR, angle QPR, is equal to 48. All right. Find arc WX. WX. Okay, so notice that XV is a diameter, and because that is a diameter, then that means this is going to be 90 degrees. Okay, and I know that this is going to be half of this guy. Okay, but wait a minute, I'm not even asked to do that. I'm just asked to find out what WX is. So since this is 90 degrees, since this is a diameter, then that means 28x plus 4 plus 17x minus 4 is equal to 180. I can add together 28 and 17 to get 45. 4 and negative 4 to get 0, so 45x is equal to 180. Divide by 45, I get 4. So since x is equal to 4, I can then figure out what WX is. So that would be 68 minus 4, 64. All right. Number 16, find angle WYX. WYX. So WYX, 4 plus 8x, is going to be 1/2 of 17x. That's just the inscribed angle theorem. So I want to multiply both sides by 2. I get 8 plus 16x is equal to 17x. Subtract both sides by 16x. I get x is equal to 8. If x is equal to 8, then WYX will equal to 4 plus 8 times 8, so that's 68. Okay. Find angle ABC. ABC. So ABC, that's an inscribed angle, so 5x plus 7 is equal to 1/2 of 9x plus 22. I'm going to multiply the other side by 2, so I get 10x plus 14 is equal to 9x plus 22. Subtract 9x, I get x is equal to, subtract 14, I get x is equal to 8. And if x is equal to 8, then angle ABC will equal to 40 plus 7, so it's 47. Question 18, very, very similar. So here instead I will subtract by 360, or actually, you know what? I'm going to find, find out what this is, right? So I know that that angle there, or that arc there, is going to be 1/2 of x plus 288. And if you think about it, you can do 1/2 of x plus 288 plus 1/2 of x plus 288 plus 3x plus 36. That will be 180. This is an alternative way of thinking about it. You'll end up with the same exact quantity at the end. So this is 1/2 x plus half of 288, that would be 144, plus 3x plus 36 is equal to 180. I want to combine like terms. 3x plus 1/2 x, that would be equivalent to 7/2 x, 7 over 2x. 144 plus 36, that would be 180. So if that's the case, then x will end up equaling to 0. And if x is equal to 0, that is definitely okay. TSR, angle TSR, is equal to 36. Okay. Moving on. Question 19. So 31x plus 10 is double that of 15x plus 8. And this will give me 30x plus 16. Subtract 30x and subtract 10 from both sides. I end up with x is equal to 6. And since x is equal to 6, I can now find PQR. PQR will equal to 98. Arc ADC. ADC is 3x plus 230. So 3x plus 230 is going to be double of 115 plus x. If I double 115 plus x, I get 230 plus 2x. Subtract x, subtract 230, I end up with x is equal to 0. And since x is equal to 0, then arc ADC is equal to 230. Which is perfectly fine. Okay, and we're almost there. So solve for x and y. All right, so this is going to be, again, opposite angles are supplementary, so I can say 7x plus 2 plus 9y plus 19 plus 18, 9y plus 18 is equal to 180. 9x plus 2 plus 9y minus 2 is equal to 180. So therefore, this is a system of equation. So if you notice, the top equation there can be re-expressed as 7x plus 9y. Combine like terms and subtract over anything that doesn't have variable. I end up with 7x plus 9y is equal to 160. The bottom equation, I have 9x plus 9y is equal to 180. I notice that I can divide or actually before I divide, because I noticed that there are common factors of 9 over here, I can just immediately subtract the top equation by the bottom equation. And if I do, I end up with negative 2x is equal to negative 20. X will therefore equal to 10. And if x is equal to 10, I can then plug it back into either equation to figure out what y is. So I know that 7 times 10 plus 9 times y is equal to 160. 9y is equal to 90, or y therefore is equal to 10 as well. So x and y are both 10 apiece. And let's take a look at this guy here. So same idea. I say 6x plus 21 plus 10y plus 3 is equal to 180. 10y minus 3 plus negative 6 plus 9x is also equal to 180. So therefore, what I will do with the top and bottom equation is I will just rewrite it. 6x plus 10y. And bring over everything that doesn't have a variable. So I will end up with 100 and, let's see, that's 24. 180 minus 24, it would be 156. Right. And the bottom equation, I end up with 9x plus 10y is equal to, add both sides by 9, 189. If I subtract the bottom equation from the top equation, I will end up with negative 3x is equal to 33. Negative 33. X will therefore equal to 11. If x is equal to 11, then I will go back and substitute 11 in for x. I get 66 plus 10y is equal to 156. Subtract both sides by 66. 10y is equal to 90, or y is equal to 9. And that's it.